learned about determinants. We talked about that determinants are a value for a matrix that help us to find the inverse of the matrix. So we're not going to specifically get that much detail like we might in a different higher level class if we were doing matrices. However, we will be using the determinant for one thing today, and that is to see if a matrix has an inverse. Okay? Let's learn about what an inverse matrix actually is. The inverse matrix, when multiplied by the original matrix, gives us the identity matrix. We just barely talked about the identity matrix. The identity matrix looks like one of these here, where we have a diagonal of ones, and then everything else is zeros. And the cool thing about the identity matrix is if we multiply a matrix by an identity matrix, we get the same matrix back again. So it's like multiplying by 1. So that's one thing we talked about last time, right? So if we multiply an inverse matrix by the original matrix, we get the identity matrix as the answer. That's one way of knowing that a matrix and an inverse are correct, that they are inverses of each other, okay? The symbol for an inverse matrix is a capital letter for the name of the matrix. So I'm using an M here for matrix, but it could be any capital letter that labels that particular matrix, and then with a -1 power. That's the notation we use when we're indicating we want to do an inverse matrix. On our calculators, when we compute inverse matrices, we are going to use the button on the calculator that has an x to the -1 power, or another way of doing a -1 power is by using the little upside down V, which is called a caret, and then typing in a -1 in parentheses. And that will also take our number, or in this case our matrix, to a -1 power, which finds the inverse. Okay? So basically a summary of what we just said. If we have a matrix and we multiply by the inverse of the matrix, we would get the identity matrix, which is that matrix with all the ones and zeros in it, right? Now here's where the determinant is going to fit in today. Not all matrices have an inverse. You can check to see if a matrix has an inverse by looking at the determinant. So that's another thing we learned last time. If the determinant is 0, the matrix does not have an inverse. If the determinant is not 0, then the matrix has an inverse. Okay, it's time for us to look at a couple of examples. Okay, for each matrix, state if an inverse exists. So all we're doing here is finding the determinant. And then by finding the determinant, if the determinant is 0, then we know that there's no inverse. So just in case you've forgotten how to do a 2 by 2 determinant, so let me change the color here. This 2 by 2, that's what this is. Determinant is where we multiply these two numbers together, and then we subtract and multiply those two numbers and find the difference between those two diagonal numbers multiplied together. So we're going to go -5 times -8. So those two numbers multiplied together. And then we're going to do -7 times -6. So those two numbers multiplied together, and then we subtract those numbers. So -5 times -8 is 40. And -6 times -7 is +42. So we're taking 40, subtract 42, and we're getting -2. So that's the determinant. Is that number a 0? No, it's not. So guess what? Yes, this particular problem has an inverse. All right, this is a 3 by 3, and there is a way to do these by hand. However, even though I make my college algebra students do these by hand, I am not going to insist that from any of you unless you would really like to know how to find a 3x3 determinant. So we are going to use a calculator, or we can use a matrix calculator that is on Desmos.com, and that's my favorite. Okay, so if we use our matrix calculator on Desmos.com, that's not quite the right screen. Did I find it? I found it. Go back to our notes. Here we are. Here's our matrix calculator. So you can see the first matrix I entered in here is this particular matrix here. I can go through and show you how to put that in here in just a second. And then after I typed the matrix in and hit enter, it stores it into Desmos for me, so that is the definition of matrix A. So then if I want to find the determinant of matrix A, I use this button right here, and then I type A and close that parenthesis, and then it gives me the answer for the determinant over here. You see that 0 right there equals 0. So I used Desmos to find that answer, and I discovered that the determinant is 0 from using Desmos. So does this problem have an inverse? No, it does not have an inverse because the determinant is 0. Okay, let's go back and just look at this matrix calculator again really fast for those of you that haven't seen it before. So to clear it out, I can just kind of go back the whole way and clear. Oh, look, there's a clear button. How far can I clear? Clear all. Brand new, fresh matrix calculator. Perfect. Okay, so let me show you step by step how to put this matrix in this matrix calculator. You don't have to use Desmos, but you can. You could use another type of calculator like the TI Inspires in our classroom, or the TI 84 Plus calculator emulator that can be found on your Chromebook. So I'm going to click on New Matrix. Notice how when I click on New Matrix, I get a 2x2 matrix. Is that what I want? Is a 2x2 matrix? Make this a little bit bigger. I don't want a 2x2 matrix, right? I know how to do 2x2s by hand. I want a 3x3. So right below where it says New Matrix, I can change matrix A so that it has 3 rows and 3 columns instead. And now I have space for all of my numbers, and I can type them in. 1, 0, -3, 2, 0, 2, and then 1, 0, -5. Okay, then I hit enter, and that stores that matrix into this matrix calculator. So now I go to this menu right here to determinant, and then I choose the letter A. And the reason I'm choosing A is because Desmos says that the name of this matrix is A. And I can hit enter, but I don't even have to. I can just see the answer over there on the right. If I hit enter, it saves it in my list of things that I've done. So I can see matrix A, and I can see that the determinant of matrix A is 0. Then, here's the next thing we're going to learn. The next thing we're going to learn is to find the inverse of a matrix. So since I've already got matrix A typed in here, the problem is I know this isn't going to give me the inverse. But if I didn't know that, I could choose matrix A again. There it is. But this time I can hit this button right here that says A to the -1. When I do that, I get a little red triangle with an exclamation point that says singular matrices do not have an inverse. Oh, look, Desmos is telling me right there. This matrix A does not have an inverse, just like we thought, because the determinant is 0. Now we're going to start doing this process on the next page of notes so that we can actually find inverses of problems that have them.